Hello people, working on this Super Cobra Jet Torino, trying to get the wide open throttle shift points moved up. It's shifting at 5 grand right now. I'd really like to get that up around 6 if I could, because max horsepower on this 429 is 5,600 RPM. So after several hours, I've got the governor out. It's a pain in the butt, okay? Here it is. Okay, first thing I'll tell you is you don't need to mess with this big valve no matter what these people on the internet tell you. That this big valve is basically like the on-off valve for the governor. When it shifts, it puts oil back up here on this port, and it shifts this valve this way. You got pressure on the back side of this valve, shifts it this way against the spring. Then, as it spins up, RPM increases, centrifugal force is going to shift this valve this way, right? And when it opens this port up right here, you're going to shift. Okay? So the question is, if I want it to get shift at a higher RPM, how am I going to do that? Well, when I took this thing out, I had this is my secondary valve, and it did have this little weight in here. This weighs 12 grams, this weighs 2 grams. So I have 14 grams in here. Okay, so if I go to my little engineering handbook, here's the formula for centrifugal force. This is all in metric. Okay, so you got force in newtons, mass in kilograms, W is angular velocity, and that's going to be measured in radians per second, and R is a radius. Okay, the radius that I'm using is 1.6 inches. It's basically measuring from the center line of this bore to basically almost the center line of this valve. And that might be a little inaccurate as far as the actual numbers come out, but this value is not going to change. So for what we're doing, okay, when we're trying to figure out the difference in weight to get the RPM moved up, if we use this same value, we're going to be okay. So there's the formula right there, okay? Now here's what we know right now, right? We know we have a 14 grams of weight, and we know it shifts at 5 grand, and we know this radius, like I just told you, is 1.6 inches, which is 0.041 meters. Everything's got to be metric, right? So that comes out to 0.014 kilograms, 524 radians per second squared, times 0.041 meters. And that's going to equal our force. And if we do the math, it comes out to 158 newtons, right? So that's our baseline, right? Okay. So now, let's say we leave this little 2 gram weight out, and now this valve, now we're down to 12 grams. So here's the calculation, right? Everything else stays the same. The unknown now is going to be the RPM when we use 12 grams instead of 14. So it's X. See right there? So we have 12 grams times the unknown. Radius stays the same, and we want the force to still equal 158, right? Because that's where we know it shifted before. So we punch it all in, right? And it comes out to 5,397 RPM. So by taking 2 grams out, we've raised the shift point about 400 RPM, okay? In theory. Now what I'm going to do is I'm going to go ahead and put it back together because I don't want to destroy this valve, leaving this out, and see what happens. And see if it really did raise the shift point 400 RPM. But I will tell you, I've done calculations, a whole lot of calculations here, and here's what I'm going to tell you. My guess is, so now what I've done now is said, okay, what if we want it to shift at 6,000 RPM? So I've raised that value. That's the radians per second for 6,000 RPM. Radius stays the same. Weight is the unknown, right? We want to know what weight will equal that force at 6,000 RPM. We do the math, and it comes down to 9.7 grams. So this thing here would really have to be lightened up like 2 more grams to get it down to 10, right? To get us up to 6 grand. But like I said, you ain't going to drill that out, okay? This is hardened steel, heat treated steel. You might be able to mill it out with a carbide carbide insert, but I'm not going to screw it up. So I'm going to go ahead and put this thing back together with this 2 gram weight out of it and see what happens, and then I'll get back with you. But my guess is, from all the research and calculations I've done, is it almost looks like you got to reduce the weight between 1/4 and 1/3 to get that extra RPM, or 1,000 RPM in it. So once I get it back together and get it out on the road and get a test, I'll get back on here and let you know how this turns out, okay? So good luck with your C6, boys. Bye.